Hello, welcome back. In this segment, we're going to look at two more repetition constructs. The only one that we've used so far is the while loop. And we can slightly more efficiently and effectively write loops using two others that exist in the C language, the DoWhile loop and the for loop. The for loop is particularly important. The DoWhile loop is used only in special circumstances, as we'll see in the examples. So here's the segment on the DoWhile loop and the for loop. Up until now, for repetition, we've been using the while loop. And here's an example, the simplest example of a while loop. We have a counter variable that starts at 1, and then we say while count is less than or equal to 3. Then output the count, and we're using our increment operator, count plus plus. So how many times will this while loop execute the body of the loop? While count is 1, the condition is true. When count is 2, the condition is true. And when count is 3, the condition is true. When count is 4, the condition is false. So this while loop executes the printf statement 3 times, outputting 1, 2, 3. Now, below the dashed line, we're going to look at the DoWhile loop. This is a post-test loop. That means that the stop condition is after the body of the loop. So it starts with the keyword do, and then the body of the loop is in braces. And we have the same behavior in this DoWhile loop that we had in the previous while loop. So when count is 1, we would output the count, increment the count, and then test it. So the first test is 2 is less than or equal to 3. Is that true? It is, so we'll go back up to the top, do the body of the loop again, output the 2, increment to 3. 3 is less than or equal to 3 is true. Back up to the top, output the 3, increment to 4. 4 is less than or equal to 3 is false, and the loop is over. So don't be confused that the keyword while is the same keyword that we used in the previous example. This is quite a different behavior. We have the condition at the bottom of the loop instead of at the top. These two loops do exactly the same thing. They print out the values 1, 2, 3, and the difference is we are doing the test at the bottom in the DoWhile. The DoWhile loop, you have to use this sparingly, only in special circumstances. Programmers don't like it because it can be difficult to read and understand the behavior of the loop. If you have several statements inside the body of the loop, I might have to scroll down to see what the stop condition is, and then back up to read the body of the loop. Excuse me, this is a waste of my time, and I would prefer not to be using DoWhile loops. I'd prefer to be able to see the behavior of the loop, including the stop condition at the top. The DoWhile loop always executes the body of the loop once. Usually more times, but always once. A while loop may execute the body of the loop 0 times. That means if the condition is false the very first time, we won't go into the body of the loop at all. Let's look now at the for loop. The for loop is the most useful loop for counter-controlled loops, and it's also the most complicated. It takes a few tries to get used to this. The people like the for loop because it's easier to read. The 3 expressions, where do you start, where do you stop, and how do you get there, are all on one line. But they're not all executed at the same time. So in these 2 boxes we have a counter-controlled while loop on the left and the equivalent for loop on the right. In the for loop, you must have inside of the parentheses 3 expressions separated by 2 semicolons. Let's look at the 3 expressions on the left. The 3 expressions meaning where do I start? In this case we say count equals 1, count gets 1. And the stop condition, count is less than or equal to 3. And how do you get there? Count plus plus in steps of 1. Now look at the equivalent for loop. Those 3 expressions appear on one line separated by the 2 semicolons. The body of the loop is executed in both cases 3 times. So in the for loop, when you get used to it, it's a little bit easier to read. We're going to look at the for loop and say count goes from 1 to 3 in steps of 1. In both cases, this loop will print out the values 1, 2, 3. The interesting part about the for loop is that these 3 expressions that appear on one line don't execute all at the same time. They don't have the same behavior. For example, the first expression is called the initialization expression, and it happens only once. It wouldn't make sense if each time through the loop we set the counter back to 1. So expression 1 happens only one time, the first time you encounter it. Expression 2 happens at the top of the loop, so it's a pre-test loop. If that condition is true, then we're going to execute the body of the loop. Expression 3 happens as if it appeared on a line by itself down at the bottom of the loop, just before the close brace. So the count plus plus in the for loop happens after the body of the loop. That means that in this example, the first value printed out is 1. That count plus plus happens after the printf, after the body of the loop is finished. We'll go into the development environment and look at some examples of where we could have used the for loop and maybe write some simple examples and step through them in the debugger to make sure that everyone has a good understanding of how the for loop's 3 expressions are going to. Well, you may remember this example from a few segments ago where we first started learning about repetition. The objective was to sum the numbers from 1 to 100 and output the result. So we used a while loop and an accumulator variable, the sum, and a counter variable, the count, all done in integer. And then we output the sum when the loop was over. What I'd like to do now is to just rewrite that code using the new constructs that we've looked at. First of all, the for loop we'll use instead of the while loop. So I'm going to make the keyword for and put in the 2 semicolons, and now we can fill in the blanks with the expressions. And we're going to, when we're done, we're going to output the sum exactly as we did before. Now, where do we start? It's expression 1, and we'll write count gets 1. And then where do we stop, or what's the stop condition? Count is less than 100. And I see that we were playing with it last time and added up numbers up to 10,000, so I'll make them the same. Count is less than 100. And then how do we get there? Count plus plus. And each time through the loop, we want to accumulate the count into the sum. So we're going to use the compound assignment operator, sum plus gets count. I have one more thing to do. I have to initialize the sum to 0 before we start. Okay, now if you look at this code and look at this code, this is much shorter. It uses the for loop, which has 3 lines of code in one, effectively. The behavior of the whole loop is described in the for loop. And we use the compound assignment operator to replace, no, we use the increment operator to replace that one, and we use the compound assignment operator to replace this one. So sum plus gets count. Okay, let's compile this and see if we've made any typing errors. It's quite possible. It says 0 errors, 1 succeeded. So I'm going to put a breakpoint here on the for loop so we can watch its behavior and make sure that everyone has a good grasp of how this counter-controlled loop is working. So F5 will run us to the breakpoint. And what should have happened already is this part of the program has completed its execution. And let's see if we can go and see that. The sum is 5050, 5050. And now we're going to look at the behavior of this loop. Here are my local variable values. Your arrangement might not look exactly like this. Your local variables, your debug windows probably are at the bottom left. I have mine floating up here so that you can see more on this lower resolution screen. Okay, so count, if we step in here, step over, sorry, the count has become 1, so we executed expression 1. We also tested that count was less than 100. We found that that was true, and we went in to execute sum plus gets count. Sum has 0, count has 1. If we execute that statement, 0 plus 1 is 1, and put the result back in sum. Now, down at the bottom of the loop, we're going to execute count plus plus. The debugger doesn't really show that happen until we're back up here. That's a little bit of a problem because you have to just kind of believe that what's going to happen now is count plus plus will happen, and then we'll test count is less than 100. So if I step over, count became 2, and then we tested 2 is less than 100. Sum plus gets count. Sum should become 3. And now at the top, it's easier to think of count plus plus happening at the bottom. The debugger shows it happening at the top, at the beginning of the next iteration, and before the test. Count became 3. 3 is less than 100. 3 plus 3 is 6, and put it in sum. And we can keep watching the behavior of this. Notice that expression 1 has only happened once, right at the beginning. You don't want to set count back to 1 each time through. So expression 1, the initializer, happens only once, as if it appeared before the loop started, like we wrote it in the while loop. And we can see this counting up. When you get tired of that, we can turn a breakpoint on there. I think we can turn this one off, and then if we F5 again, run to the next breakpoint, it completed executing this loop. When count became 100, the loop was false. And we have a bug. Oh, this is good. I'm glad. We haven't made many mistakes during these, and I didn't get the right answer. I got 4,950. We were expecting the answer 5050 to have the same behavior as the while loop, and there's the bug. I didn't get the expression, the relational expression, exactly correct. I should have put less than or equal to, so that this loop would have finished at the right place. This is a very common bug. In fact, it has its own name. It's called the off by 1 bug. When your condition has your loop stop 1 place too early or 1 place too late, for what you intended the behavior to be, the off by 1 bug. So if we finish this, we would see 4950 is the result using the for loop, which is incorrect. We're off by 1 iteration of the loop, and it's because we wanted an equal sign there. Less than or equal to is the relational operator. Let's do F7 and then F5, and we'll see that the behavior this time is that the sum has 50-50, and the first time this condition was false is when count had 101. So when the condition is false, and only then will we jump out of the loop, fall out of the loop, and continue executing the statements after the for loop is over. Good. Well, I'm glad that we finally have typed a bug in a loop and seen that the debug process using these breakpoints and iterating through is helpful. You'll make all manner of mistakes, mistakes that I can't even guess you might make, and that will help you to, the debugger will help you to find those mistakes very quickly, hopefully, and minimize the frustration. A lot of people will find writing for loops frustrating at first because they don't do what you want them to do, and you just have to look very carefully at exactly what they're doing, and you can be sure that the machine is doing what you told it to do. Now we have the behavior that we want. Just a brief review of the concepts that we've looked at in this segment. We looked at 2 new loops, the DoWhile loop and the for loop. The DoWhile loop is frowned upon by many because it's a post-test loop. You execute the body of the loop and then test whether to do the body of the loop again. In some circumstances, this is the right choice. I don't want to tell you that you should never use this. People do use it, and you'll get comfortable as you just write more code, whether you should be choosing the while loop or the DoWhile loop. The for loop is a little bit more clear. You should always use a for loop when you are doing a counter-controlled loop. And you don't have to. We've been using the while loop for counter-controlled loops. But programmers in C generally like to see the 3 parts of the loop on one line of code, which is what the for loop allows us to do. So if you're writing a counter-controlled loop, you probably should be using the for loop. And if you're writing a sentinel-controlled loop, you should be using the while loop. And in certain circumstances where you want the body of the loop to happen one time, then you should be using the DoWhile loop. I hope you're enjoying this, and I'll see you in the next segment.